Just a second. Son of the Holy Spirit. Amen. Lord, we thank you for the gift of life. We thank you for another day of learning, another opportunity to improve ourselves. We ask to come and take absolute control of everything we are going to do. Come and bless every of our works of our hands, and may this be a fruitful endeavor, and may it benefit us at the end. This is a minimum we ask to Christ our Lord. Amen. Can you confirm you can hear me?
Oh yes, we can hear you loud and clear.
Okay, good. So we begin. I'll share my screen. Can you enable me to be able to share my screen, please? Thank you. Mhm. Okay. So we're really here today to do what I'll call a volume two, something we've already done before. So it's like a repeat lecture for those who are not able to make it, because we did try to have preceding kind of mentorship sessions, but unfortunately, the platform I was making use of did not permit for free versions. You had to pay basically to get a session with the mentor. So we had to improvise and decided to do another session where we can record it and have it shared among, even those who are not able to attend, or in case you want to use it as a reference point or something to use and revise in case you forget. So we decided to record this session today. So once again, I want to say thank you to everyone for the opportunity to do this. I'm really honored to do it, and I'm hoping that at the end of this seminar or session, we're able to pick a couple of things to take home and become more proactive in our decision to take on careers in tech. So we'll begin now. We're talking about tech careers in 2023. So let's dive in really. First of all, let's talk about your facilitator. For those who might not know me, my name is Martins Okafor. Uh, I've been in tech for a very long time. To be precise, over 17 years, really. So I have worked in various tech roles, mostly in IT support and software engineering. The most recent roles I've handled is a lead role in NL, engineering manager role in Dictate, and presently engineering manager at National Grid. Um, I have worked as a front-end developer engineer. I've worked as a full stack, what you could just simply call a software engineer. And I've worked as a TNT specialist. So some of the things I enjoyed using, some of the technologies or stack I've enjoyed using over the years are HTML, CSS, JavaScript, Java, Python, React, Knockout.js, Redux, Mobex, Docker, Jest, MongoDB, and the list goes on, just to mention a few. So without wasting your time, let's dive in. So we'll be looking at careers in software engineering. We'll be looking at data science, UI UX design, artificial intelligence, cybersecurity, graphics designer, network security, database management, IT support, or what you might call a technical support technician or whatever, cloud engineering, product manager, a QA analyst, that's quality assurance analyst, basically for IT. So as you can tell already, the tech world, tech engineers, tech specialists, they are being paid very well. Um, Although right now there's a lot of panic about what AI is going to do to a lot of tech jobs, and we're going to talk about it. So the rest assured we're going to be touching during the course of this what you might call a mini lecture. So you can see some of the average salaries of tech people. And trust me, this is just average, meaning some people can earn a lot more than this, depending on what level or where you work, you know. So I don't want to waste time to look at this later. This is public knowledge. You can Google it, see what the average salary for these tech roles are. So let's not waste time with it. Let's begin with software engineering. What do you need to know to get started? And I'm talking about the bare minimum to get started, first of all. And I'll talk about how you can begin to extend until you go to a point where you can call yourself a senior developer. The bare minimum is HTML. One of the things I would say is this: the first thing you should start with is HTML, because like I said, it is like for architects, it's like the framework, the backbone of every application, every website, whatever you want to design. That is mobile application. Sometimes people use it, we should be talking about as we proceed or we progress into the course. So HTML is the first thing you must begin. I'll show you sample of these things as we progress. I'll show you some of what HTML looks like so you understand. So you are able to decide if it's something that you think you can dive into. So we're just looking at snippets of some of them, if I'm able to access them. Then we have CSS. CSS basically is you beginning to give colors, vibrance, size, all those things, giving them properties as to those HTMLs. That's your text, what to decide the size, the color, what the text, the behavior of those tags, HTML tags you have in your website or your web application. Then JavaScript begins to give them actual functionalities of behavior. If you want them to do certain things, like if you want dynamic data and all those kind of things, that's when JavaScript begins to come in. It gives them actual behaviors and functionality. Now, there's TypeScript. TypeScript is a superset of JavaScript. TypeScript was introduced because JavaScript is not, very strict about data types, unlike things like Java or even C#, where you define certain data types. JavaScript is basically not so strict about it. So in JavaScript, you can have a string of one, for example, a string number one, not necessarily a number, a string of one, adding a string of one, and it will become 11. So imagine that kind of error in your application where you're expecting it to be 1 plus 1 equal to 2. It becomes 1 and 1 equal to 11 because it's seeing them as strings. So TypeScript was introduced to help what they call type protecting, so that you are able to define what kind of values you're expecting, even if you're getting it from the users, like from an input form, is able to decide that these values are strictly to be numbers, not string. So if for example, I was to send as a user a string, it will flag up an error or something like that. A lot of it's way much more complex than that, but just a simple example of what I'm trying to say. So it helps developers to be more type strict, with the application, and it avoids error. That's the essence of TypeScript. But TypeScript really is just let me say, an added functionality of what JavaScript should be. So if you know JavaScript, it's not too difficult to learn TypeScript. So I will still insist that every developer, the first 3 steps you must take is to learn HTML, CSS, and JavaScript. Now, how much time do you give to? I believe strongly that if you can give HTML, even if it's 2 hours every day, in 2 weeks you have learned enough HTML. Why did I say you've learned enough? You don't have to remember everything. But whatever you forget, you can Google. Just know how it works, how to use them, how to get. But even if you get something for, let's say, Stack Overflow or from W3 schools, or any of those are good application resources for developers, you know how to apply them, how to use them. So 2 weeks of HTML is more than enough time. You can move on to CSS, another 2 weeks, as if you're giving them at least 2 hours every day, another 2 weeks. It doesn't mean you become very good at it. It means you still be referencing a lot, but it's a start. Like, I'm trying to tell you how to start. the more you use them, the more you invest more time over time, because I've written HTML and CSS for over 17 years. So it now comes to me like a second nature, but I'm not asking you to take 17 years before you don't have to, everything doesn't have to be in your head. I write them off my head now, but it's okay to reference. That's what I'm trying to say. If you want to begin, it's okay to reference. The more you reference, the more you write them, the more you write it, repetition begins to make them stick. Now they start becoming a part of you. But for JavaScript, now I would recommend you give JavaScript at least 3 months. I can almost say 6 months. It depends on how quickly you learn. If you are doing just 2 hours of JavaScript, 6 months is my recommendation. If you're able to do more than 2 JavaScript, then maybe, depending on how quickly you're able to pick things, maybe 3 months, 4 months might be enough. Why did I say so much that for JavaScript? JavaScript will give you a good foundation of whatever you want to learn tomorrow. Even if you decide to want to learn C Sharp, React, because React, Angular, Vue, they are all frameworks of JavaScript. So, like when I learned JavaScript, when I wanted to pick on C Sharp, I realized that it was so easy because it was just a change of syntax and then just a few things, of course, but it was so easy to pick it on because I mean, it's JavaScript has given me a foundation. You're still working with if statements, for example, look, or you're still working with those familiar things that you already know. The data types are not so different. They might just the syntax might be different, but it's still data types. So that's why I said give JavaScript at least 4 to 6 months, depending on how quickly you learn. If you learn these three things, you are very, very, very ready to begin as an intern or even a junior developer. You just have to learn a few other things that will help you, like GitHub. You can see I've jumped to repository software. You can learn GitHub, Bitbucket, or GitLab so that you are able to collaborate and work with teams. I don't know if you want to see what GitLab looks like, but I'll show you some of these things later. Just remember, you see that they're just basically a way for teams to work together. We'll still talk more about it, but just to hint at what it does. Before now, developers had to, basically use flash drives or any form of drive to copy their codes, combine it together, and then, share it with each other. So developer A and developer B and developer C might be working. They work on different parts of the code. At the end, they'll come together and combine it, which is a lot of work. And then they'll not share what they've combined among the three of them, and then guys start working on other things again. So GitHub and all the repository softwares, the idea, GitHub is the first anyway. The idea was to help make collaboration easier and faster. So you need to learn one of those, basically Git commands. You can use any of them, any of the applications, but you have to learn Git commands. Basically, how to commit your codes, how to do a pull request, a push request, and how to merge and all those things. If you've learned these things, you can actually become some sort of a junior developer as a software front-end engineer. Now, if you want to go forward, because it's not enough to be fair, most people are hiring now, they want to know at least one of these three things: React, Angular, or Vue, which are JavaScript frameworks. And these days, everybody wants to know that your TypeScript is strong because everybody wants to write codes that are more free from error. So that's where you now begin to learn TypeScript and JavaScript frameworks. But remember what I said, for those first three, you can start a job. Some companies are willing to hire you, and then as an intern or as a junior developer, and then you start learning. You will not earn what the seniors are earning, obviously. It will take you some time, like it will take you a couple of years. You will climb the ladder. It's part of the process, and there's nothing wrong with that. But if you want to say, okay, I want to move further, because most of the time, when you start working for these companies, they will be doing what they call progression reports on you. They expect you to grow, they expect you to keep learning. So they will give you access to things like maybe all these learning platforms, like what they call it, any of those, or what they call it, or the name is not coming to me, but basically any of those learning platforms, they used to have what they call a premium access to them. So you can go and learn any of the things you want to learn. You can, for example, get a whole course on TypeScript and learn for hours and days and keep learning. So TypeScript is the next thing you should learn. After TypeScript, learn React, because React combines with TypeScript to get better results. There's TypeScript in React, there's TypeScript in Angular. So basically, combine TypeScript, then learn React.
Don't mute, Abby.
Or can you hear me?
Yes, we can hear you.
Can you? Okay, all right. So you either pick React, Angular, or Vue. The most popular is React. To be fair, for you, I'll pick React. Now, why did I say React? Because React is so popular, because it was made by Facebook. In fact, the whole of Facebook, the applications like this one they use for Airbnb, a lot of these popular applications, even your Netflix is React. It's powered React. And you remember the old Facebook, if you remember then that if you go on Facebook, if a notification should come while you're on the page, you have to refresh the whole page for you to see that you have a friend request or you have a new, basic notification. But with React, it refreshes itself in real time, just the components. It does not refresh the whole DOM. That's technical stuff I don't want to go into. It's so good that it's so lightweight that it doesn't refresh the whole DOM. You don't have to, every time control R to see what's happening. As things are changing, as data is being received, it is changing the parts of the component, because everything in React is components. It's changing the parts of the component that needs to change. The other parts remain the same. As long as they do not get new data, or a reason to refresh, they remain the same. And that was revolutionary for web applications. So a lot of powerful sites are using React today. So when it comes to state management became far more complex over time. React has a way of managing states, like use context and the rest, but it became so complex. Applications like Redux had to come into play, Mobex and the rest of them. So Redux, boilerplate and other. So if you're learning Redux today, I will recommend you learn Redux Toolkit. I hope you're taking note of this. If this is your interest, learn Redux Toolkit. Mobex is not so popular. I had to learn Mobex because of certain jobs I did. But Apollo and Redux are the most popular. Then when it comes to testing, Jest is the most, there are three types of testing really. There is end-to-end testing, which is what Cypress really shines at doing. There is integrated testing, that's combining different functionalities together, different functions, because everything in programming is functions and objects and others. So combining them together to see how they work well is called integrated testing. Then unit testing is basically testing one particular function or functionality. So we'll talk more about it a bit later. I'm trying to be a bit faster because there's a lot to talk about. Then APIs and SDKs, you have to be very familiar with them. For front-end people, you don't necessarily have to know how they are designed. That's APIs and SDKs. But APIs and SDKs, you might ask what's the difference. They're not so different, really. They both have mix of getting different routes and getting different methods, or what you might call a controller, and then making it available to the front end as APIs or SDKs, excuse me. Then CI/CD, that's continuous integration, continuous deployment. You just for foundational knowledge of CI/CD. You don't have to be so deep into it. You're not a DevOps engineer. A DevOps engineer needs to know this back to back. But the front end should know some part of it, especially when you want to roll back certain parts, or maybe your application is having some issues. You want to roll back the application to the last time it was good. You need some basic knowledge of CI/CD. Then cloud technology is not necessarily new, and I hope you understand what cloud really is. But I think I'll still get the opportunity to talk about it a bit later. So just have knowledge of Azure, AWS, any of them is all good, but the most popular is the first two that are listed there. Then let's go to backend. Backend, there are a lot of things, a lot of applications in backend, but the most popular, I would recommend that you should go into either you're learning PHP and SQL, or you're learning Node.js. Node.js is so popular that most of the interviews, everyone from Node.js. And Node.js, there's a package called, or what you might call a library called Express.js. So if you learn Express.js just makes Node.js a bit easier to write. So Express.js is part of what you might call, for a full stack developer, you are learning MEN, which I think I'll talk about later. So Express.js is just a part of it. Also learn Python. Python can be used for backend too, but my recommendation is PHP and Node.js, paying attention to Express. Why am I recommending this? I'm looking at what the market is looking for. That's why I mentioned it. Other things are not as if they're not useful, but the market is looking for these things. So for database, SQL and MongoDB. SQL is completely SQL. MongoDB is non-SQL, or it's easier to write basically. Then GraphQL is basically a good replacement, a good way of writing your APIs. I don't want to be too technical, but APIs can be more complex when you're writing them with things like Node.js, because you have to define different routes for different things. But with GraphQL, it's just one route, basically just the query that'll be changing. And this is a bit technical. You don't have to bother yourself about it for now until you're ready that if this is what you really want to do, then you can bother about it. I'll show you an example what I'm talking about so you see what it looks like. And I'll walk you through it, but hopefully, I hope we have enough time to do it anyway. Like I said, PHP is one of the things you can learn. Laravel is a specific type of PHP. Then API development environments like Postman, Insomnia, and Swagger are things you have, tools you have to test your routes, to test your controllers, to ensure that they are working. Your API development environments, it becomes important. Then for DevOps engineers, you're talking about Docker, CI/CD pipeline, like I already said earlier. A good understanding of Linux and command lines is important, because a DevOps engineer is going to be writing a lot of commands, and most of them are similar. So if you have a good understanding of Linux commands, then it will be a lot easier to dive into DevOps, in my opinion, anyway. I consider myself a full stack engineer. I write both front end and back end. And MEN is the tool I use. What is MEN? MongoDB, Express.js, which is Node.js, React, and of course Node.js. Node.js is listed separately again to tell that they're not the same. Express.js just makes it easier to write Node.js. But there are sometimes that some things you have to write precisely in Node.js. Then there's GraphQL, there's Python, there's SQL, there's PHP, there's C#. All these things are tools you can use for full stack. These are the most popular in the market. There are a lot more out there, but these ones are the most popular in the market. Then what do you need to know to get started as mobile developer? We talked about desktop and web application. Now we're talking about mobile now. For native mobile development, there are two types, basically. It's either you're designing for iOS or Android. Those are the two platforms out there. For Android tech stack, there's Java and Kotlin. Those are the two most popular. Anything I mentioned to you here are the popular ones, so you can take it to church. It means that if you learn any of these tools, you are hireable, you start earning some good money. Kotlin means less code to type because it's a lot easier. But Java, like I said, learning Java makes you a more robust, more, it's just like Python. Python is so robust that there's Python for data scientists and there's Python for software engineers. They are not necessarily the same, but it's still Python. Just that you have to learn different things in that Python, for lack of a better word. Then for iOS tech stack, we have Swift. I'm sure you've heard of Swift before. It's very popular, and Objective-C. Objective-C is just a superset of C, but I recommend that you use Swift, as I wrote here. Now, a hybrid is a blend of both native and web solutions. We have a tech stack called, like I told you before, remember I mentioned, I said you can even use HTML in some web applications if you have the right tools for using it. If you have frameworks like Apache Cordova and Ionic, you can write your mobile applications using HTML, CSS, and JavaScript. So you see that even with those skills, you can even still move into mobile application with a good framework to help you basically under the hood convert some of the things. So Ionic is like an SDK. So SDK is software development kit. What it actually means is that it has predefined, pre-prepared APIs, methods, and all those things that all you have to do is just use them. They're already defined. That's why you see that sometimes when the company is being acquired or doing acquisitions, SDKs are part of the things that are handed over to the people acquiring the company. It means that they're already defined. So that's why every developer, especially in the back end, they keep all these things ready to, like a bundle. You can just with the keys, the right keys, you can access all the methods, all the routes, and from the back end, make it available to the people around it. That's like bundling them together. That's what SDK really is. So it works well with frameworks like React, Angular, and Vue. There's also cross-platform development, creating apps that run on multiple platforms. And React Native is the most popular. Just learn React Native and go and sleep. In fact, if I was to pick mobile development today, React Native is the first on my list. Then maybe I'll go into Java and the rest of them. So I hope this was helpful. There are some useful principles. I don't want to waste your time, but what this simply means is the solid principle is a way people approach tech problems or approach new applications. Maybe you wanted to work on a new project as a developer. The way you approach it, there's what they call solid principle, that's single responsibility, open close principle, Linscov principle. There are a lot of them. All they are doing is, if you learn these principles, some people actually look at it when they're interviewing you, especially when you're doing live code. They will ask you to write the code and they will watch how you approach it using these principles. So some of the popular principles are there. Solid principle is one of them. Dry simply means do not repeat yourself. One of the things that makes you a good developer over time, so you begin to assess yourself, you realize that you could try to solve a technical problem and you're using 200 lines to solve it. Another person is using 50 lines to solve the same problem. It's because one of you is repeating himself a lot. So the better, first of all, the approach might be to, especially as you're learning, the approach might be to first of all write the code anyhow it is. Let it solve the problem. Then look at the code again. Look for how you can begin to stop repeating, put them into functions so that they can be reusable. So you can call that function and give the parameters. All those things begin to reduce the lines of your code. That's how you become a better developer. So do not repeat yourself. First principle, TDD are both ways of writing testing. So I would not waste my time. I would not waste your time with this because it's too technical. Then, of course, cloud, you already know what it is. Okay, let's do something before we jump into artificial intelligence. Let me show you something. I hope this will help drive from some of the message. I think we just have 1 minute left. Perhaps by the time I'm done opening this, we can restart the call, rejoin so that I can show you what I want to show you. I don't think we have enough time to go into this, so let's just restart the call. Uche, you can start the call if you don't mind.